Next one.
I have a good one.
Now I'm adding with different signs. I'm mixing them together. When I am adding integers with different signs, step one, make sure I keep this consistent. I am going to subtract the smaller or lesser absolute value from the greater absolute value. Use the sign of the greater absolute value in the sum. Okay. So in this one, I have positive 3 plus negative 7. Some of you guys in that C-level activity were asking me, is that supposed to be an absolute value bar? No. And whenever you did ask, I explained to you the reason we put parentheses around a negative numbers like that is because I don't want you to look at that as like 3 plus minus 7. Okay, that it's 3 plus negative 7. So you're going to start seeing that more as you get more into like the algebra units and as you get into upper level math, you'll see them separated just like that. Okay, so if I have positive 3, I'm adding negative 7, I'm actually going to be subtracting the absolute value. So what is the absolute value of 3 and negative 7?
4.
3 absolute values. We're not doing anything with them yet. What are the absolute values of 3 and negative 7? 7 and 3. Remember, you remove the signs. Don't forget, absolute values, you remove signs completely. So it's just 3 and 7. Plain old 3, plain old 7. I will subtract those. So the bigger one is 7. Subtract 3. What do I have?
4.
I have 4. Now, I got to use the sign of the greater absolute value. The bigger absolute value in this one is 7. So my answer is also negative. Correct.
Yeah, but when you're using negative. But when you add a negative, it's just like subtract.
Think about if you have $3 and you're adding negative 7. Okay, you owe $7. You're in the red. You're negative $4 in the hole. Okay, this time look at my numbers. I have negative 28 plus 13. What are the absolute values of negative 28 and 13?
28 and 13.
28 and 13. So I'm going to pretend like I have no symbols right now, and I'm just going to subtract 28 minus 13, which is 15. Which one of those absolute values which one is bigger, 28 or 13?
28.
28. So I'm going to use a symbol that is attached to the 28, which is negative. So my answer is negative 15. So I did 28 minus 13. Over here I did 7 minus 3. That's how we ended up with our answers. Okay, do y'all want to try the next one, or do you want me to go over it with you?
We should try it.
Y'all try it. Y'all try the next two, and then we're going to look at counters. Okay? Okay, let's check over these two. We're going to finish our notes tomorrow. So 15 and negative 14. Absolute values are 15 and 14. So I do 15 minus 14, which is? 1.
15 greater than negative.
I need everybody's attention in 3, 2, 1. I know we're about to leave, but hang on. The absolute value of 15 is bigger than the absolute value of 14, and because it's positive, my answer stays positive. Now look at the next one. Absolute values of 54 and 27. I'm going to subtract those. So my answer is going to be 27, but I'm going to use the sign of the larger absolute value number, which is negative. So in order to get that again, I did 54 minus 27. Here I did 15 minus 14. Okay, we'll do the counters in the number line tomorrow. Go ahead and make sure you have everything you came with. Okay, when we are modeling adding integers with different signs, you can use counter chips. So those are the little red and yellow that I showed you on the previous notes, and some of you may have color-coded with me. So we're going to show what that looks like, and then I'm going to talk about something that you're going to notice with our counter chips. So the first thing I'm going to do is I'm going to go ahead and color each one of these. I have 5 positive plus 8 negatives. So each one of these are going to be color coded. You're going to have these in just a little bit, and you're going to actually be modeling some problems so that you can see what's happening. With these, you're going to see something that we call zero pairs. So a zero pair is, I got to make this smaller so I can write again. A zero pair is whenever you have a positive and a negative counter chip, they cancel each other out, and we call that zero pair. So this is a zero pair. This is a zero pair. This, and this. These are all called zero pairs. So they basically equal 0. So that means that what I have left right here is my answer, -3. Okay. The other thing that we're going to talk about today is how to add integers with different signs on a number line. So we did this with integers that have the same sign and the arrows go the same directions. Did anybody see a question like this on their NAWIA yesterday? Because I had some showing me this and they were like, I don't understand. And I was like, ooh, we're actually going to do this in our notes today.
I got it right because it did a super hard question right off.
So this is what it's going to look like. You will always start at 0. I hope you are listening, paying attention. If I draw, you draw. If I write, you write. Because you've got to know how it looks. You've got to know how to come up with the equation if you're just given the number line. And you've got to be able to come up with the answer if you're given the equation using a number line. So you may have a question, for example, that has this problem and it says which number line represents the equation. And you have to choose A, B, C, or D, which answer has the correct number line showing that equation. Or it may say, using this number line, what is the equation shown? And you have to be able to go backwards and forwards with that, okay? All right, so the first thing I'm going to do is I'm going to show what -8 looks like. So that's going to be my first line, which will be closest to the number line. So I'm going to start at 0, and I'm going to go to -8. 1, 2, 3, 4, 5, 6, 7, 8. My arrow tip is right at -8. That first integer is closest to the number line. Now I'm going to draw another line right above it, and I'm going to show +5. Because it's plus +5, I'm starting at -8 here, but I'm going to go which direction? Right. 1, 2, 3, 4, 5. And where the tip of the arrow ends is my answer, which is -3. Do you guys want to try the bottom one, or do you want to do it together? Okay, try it and then we'll check it. I know you can solve it, but can you show it? Okay, where does my line, my first arrow go? The one closest to the number line. It goes to the right 7 places. Then where does my next line start?
Left 8 places.
Yep, starts at 7 and it goes left 8 places and it ends at -1. Easy enough? Okay, we're going to do practice today with counter chips. So I'm going to pass those out and explain our activity to you. Keep your journal so that you have those examples if you need them. Okay, today we get to learn the algorithm, but we also get to see modeling adding integers. We're going to talk about adding integers with the same sign, and we're also going to talk about adding integers when they have different signs. So you got to explore a little bit of both with that C-level activity. So you could see on the number line what was happening when you add a positive versus when you add a negative. Okay, when adding integers of the same sign, if I'm writing, you're writing, add the absolute values of the integers. So make sure you're on the right side. It should say 3.1 on your notes. If you glued them in reverse order, that's okay. Just make sure that your table of contents matches your journal and that you're on the right page with this right now. Okay, so you're going to add the absolute values of the integers. Use the same sign for the sum. Just a refresher. Sum is what?
adding? Result from adding.
The answer or the result from adding 2 or more numbers, okay? So if I'm looking at this example right here, it says negative 5 minus 3. That is actually the same as negative 5 plus negative 3. I know that seems weird. It's the same thing. So if I'm subtracting a whole number, if I'm going down on my number line, like our C-level activity, or if I'm moving left on a number line, and I am adding a negative number, I'm really subtracting. Unless I'm already starting at a negative. I'm still going further to the left or further down my number line, but I'm actually going to add those 2 numbers together. So I'm going to actually take 5 and 3, the absolute values of negative 5 and negative 3 are 5 and 3. I combine those amounts together, which is 8. But because I was already in the negatives, it's going to stay negative, so my answer will be negative 8.
Negative 8 garage.
Imagine it on my number line for a minute. I was standing back here because I needed to see if everybody could see my number line. It's the C-level one. Okay, if I'm at, y'all can't see over here behind me. If I'm at negative 5, and I am going to add negative 3, or like my example says here, negative 5 minus 3. I'm here. I subtract 3. 1, 2, 3. I'm at negative 8. Okay? So the rule is you take the absolute values of your numbers, if the signs are the same, go ahead and add them like you normally would, and then apply the symbol, whether it's positive or negative, that they already were, to your answer. Okay? Now, what does that look like with numbers or counters? Okay, I'm going to use red and yellow because when we start using counters, that's what they're going to look like. So one side will be red, one side will be yellow. Red represents, anybody want to guess? Negative. Yellow will represent positive. Okay, so remember, negative plus a negative will always equal a negative. But a positive and a positive will equal a positive. So when I am working with these counters, I'm going to be using red and yellow. Okay, you can do the same or you don't have to. So if I have 4 plus 3, that's going to be represented by 4 yellow counters because it's positive 4 plus positive 3. So what is my answer going to be? 7. This is very simple because they are both positives, and that's what we're used to. We are used to seeing positives and positives. Okay, well, what if I have negative 5 and I'm going to add negative 2 to that? So all together, I have negative 7. Okay, the next one, I have negative 8, and then I have negative 4 that I'm going to add to my negative 8. All together, how many negative counters do I have? I have negative 12. Don't forget your negative symbol. If they are negatives, it stays a negative. Okay, here are some practice problems. You have them written 2 different ways. Again, don't forget that a positive and a positive, when you add them together, makes a positive, and a negative, when added together, equals a negative. All right, here we go. Positive 38 plus 5 is? Nothing tricky about that. Y'all, I'm telling you, when we start doing adding and subtracting integers, you start second guessing yourself with the basic positive numbers. You're like, because you've got so many rules you're trying to remember. Even something this simple, like what we're used to, starts to become confusing because you're trying to remember your rules. Okay? You know it. Don't second guess yourself. You know it. Okay, 12 plus 15. 27. Negative 20 plus negative 8. Very good. Y'all are so smart. Okay, negative 14 plus negative 6. Yes. 13 plus 7. Negative 9 plus negative 14.
Negative 23.
Very good. Okay, how will this look on a number line? Okay, this is where it gets a little different. A little different. Okay, when I am adding two negatives together, I'm going to show this. You've got to do this with me. Okay, so whether you're using a pen, a pencil, a marker, I don't care what you're using, but you've got to make sure you draw how I draw. When I draw, you draw. Okay, so on a number line, notice my 0 is way over here. I'm going to represent my first number first. I'm drawing two lines. You're going to see this in just a second. Okay, so I'm going to have negative 5. I'm going to start at 0, and I'm going to draw a line to negative 5. So 1, 2, 3, 4, 5 right here. This represents negative 5. Now, how do you think I'm going to show that I'm adding negative 8? I'm going to start here, and I'm going to draw another line moving left 8 places. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now I will combine these two pieces together. I am showing the distance because, remember, signs are the same, so I'm really looking at the absolute values of my numbers. So I'm looking at the 5 here plus the 8 spaces here, and I end up at negative 13 because I want to keep this sign the same. I was working with negatives, it's still a negative. When I am adding negatives, I move left. Now let's look at positives. I'm just going to use blue because it's easier to see than yellow on the board. Okay, to model this, I would start at 0. Everybody see 0 over here by the car? Or the car on the left, I should say. Okay, so I'm going to start by showing 7. 1, 2, 3, 4, 5, 6, 7. If I'm drawing, you're drawing. Nobody is sitting there not drawing with me. Guys, these lines are important. If I give you a practice page and it says model the integer problem using a number line, you've got to understand this. You've got to be able to do it. Right now it's simple because the arrows are going the same direction. If I hand you a paper and I say, show me the problem, give me the equation represented by the number line, you should be able to tell me what equation is represented by the number line. When I do, you do. When I write, you write. When I draw, you draw. It's super important whenever we're learning something new. Okay, so this represents positive 7. Now I'm going to show adding 3. So 1, 2, 3, another 1. And then my last one will be one more. Because I'm adding positive, 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 I end up at positive, what? 11. When I add positives together, I keep moving which direction? Right. I know this seems silly maybe to some of y'all. You're like, why are we doing this? It's because as we start mixing up our signs and symbols, it starts to get a little bit more confusing. So we're starting simple, basic. Okay. How do we feel so far? Okay, I've got some goods and some thumbs ups. All right, let's go.